To visualize a solution to a system of linear equations, we're going to have to draw a picture. So when we go back and just look at a single linear equation, linear means it's a line. If this is a single linear equation, every spot on here is a solution. That's why it forms a line, because there's infinitely many ordered pairs, x's and y's, on that line. Now, if I was looking at a system of equations and wanted to find its solution, that means it's going to be an ordered pair, x and y, and that solution satisfies all equations. In other words, that ordered pair would uphold the equal sign to all equations in the system. There's no limit to the number of equations in a system, but a solution must satisfy all equations in that system. So what will they look like in a system? Let's just focus on two lines. If I have a red line and a blue line, they may intersect at a single point, one solution. Where is that solution? Right at that intersecting point. That is an ordered pair that is on the blue line and also on the red line. So this xy would be a solution to that system. Now we have some other cases that may happen. Again, we'll keep the color of these lines, and in this case, the two lines are what we call parallel. And in this case, there is no solution. These lines do not intersect, so there is no ordered pair that works for both red and blue line. In the third case, we have this blue line, and what really might happen, it seems awfully strange that you wouldn't recognize it, but we can disguise it a little bit and notice the red line lies right on the blue line. So how many solutions would they have? How many ordered pairs would they have in common? They would have all of these. They would have infinitely many. So they have infinitely many solutions because they end up being the same line. So how can we find these solutions? There are three methods. We'll look at the first method, graphing, and when we graph systems, we like it in this form, y equals mx plus b. In other words, we like it to be in slope-intercept form, so my lines are easy to graph. So what are the steps in finding the solution? Well, the first thing is you need to graph the equations in the system. So you graph them. Then what you're going to look for is that point of intersection, recalling that you may have one point, you may have no points at all, or you might have infinitely many. And then the last step that you should always do, especially when graphing, is check your solution in all equations in the system. You want to make sure that you graphed it correctly and accurately. Graphing is a little bit inaccurate unless, of course, you're using technology. So notice I have two equations in my system. They are both of the same variable. I'm going to graph the first equation in blue. My y-intercept is 5, which will put me just at the top. My slope then is that -3. I always like a rise and a run. Negative tells me to go down 3, so 1, 2, 3, and over 1. I'm going to kind of repeat this a few times, down 1, 2, 3, and over 1 from each of the last points I graph, so I can get a fairly accurate straight line. Graphing the second equation in my system using red. Y-intercept is down at -3. My slope has a number out in front, which is 1 over 1, which tells me to rise 1, run 1, rise 1, run 1. And again, I like to apply that slope a few times so that my line is more accurate. And again, I still didn't graph it great, but I can see that right there is my solution. So what is that ordered pair? Well, looking from the origin, counting over, it looks like my ordered pair has the value over 2 in the x and down -1. Here's my origin, over 2 and down -1. So I found it visually. Now we better check it. In other words, I'm going to take my y coordinate and I'm going to plug it in for y, my x coordinate in for x, and I'm going to test to see that this is in fact a solution, and it is. Let's plug it in my second equation, -1, which is y, x minus 3. 2 minus 3 is -1, and it works in both. So this ordered pair is a solution to my system of equations, and that's how we find it visually through the graphing method.